So we already learned a lot about the stack. Yeah, if you still remember this step, you may understand all the main stack operations, which is push and pop. And there are some other methods, auxiliary stack operations like top, length, and SMT. So we learn about the code also in the Jupyter lab. And yeah, we learned there are many applications that we can do with stacks. And we already reached this section. Yeah. We already reached about the tag matching. So we want to find whether the tag in HTML is matched or not. And this is the code. You can see also the code that I give to you in the Jupyter lab. So we have the it's match.html. If you run this code, oh, sorry, I need to run the array stack. So the array stack is the ADT. We call it the ADT because it is the abstract data type. Whenever you want to apply to implementation, we need to call this array stack. Okay, we need to call this array stack. It means the array stack is the program or the code that you can use in any implementation. The implementation that you see here, one of them is to do with the parenthesis matching. Okay. And then the second implementation is the HTML matching. So we use the array stack for the parenthesis matching. We use the array stack for the HTML matching. That's why we can say this array stack is the ADT or abstract data type. And we can also see one other implementation, which is to evaluate the arithmetic expression. How we can do this one? Let's say I have this operation. 14 minus 3 multiplied by 2 plus 7. And if you still remember with the programming, we will do the arithmetic expression based on the precedence rule. Do you still remember what is precedence rule? We will do by the order of priority. Multiply, division will be first, and then minus, plus will be next. And if you have a kind of parenthesis, this one, then it will be also priority. And associativity. Operators of the same precedence group evaluated from left to right. If we have x minus y plus z, this one will be evaluated like this one because the sequence of the programming language is this from left to right. Okay. If you use the parenthesis, then of course they will make the priority for the parenthesis first. So y plus z will be first, and then we will do the minus with x. So the idea is we want to push each operator on the stack, but first pop and perform higher and equal precedence operations. Okay, let's see what does it mean. In this implementation, yeah, we include additional operations. We include additional functions. At first, we want to prepare two stacks. The first stack is to hold the operators, and the other stack is to hold the values. Okay, operators, it is the plus, minus, multiply, division, and values, it is the number. Okay? Maybe 3 or 15 and so on. And we can use dollar as the special end of input. So this dollar sign, if we finish with all the operation, then we just pick dollar. Actually, this is just a value to understand that you already finished with all the arithmetic operations. You can define with other symbol. Okay, yeah. Yeah. So this is the first algorithm, or we can say this is the first function. I would like to do pop. I will do the x. Yeah, x will be pop, and then y will be pop, and then op, yeah, will be also pop. But you can see the x will be pop in the value stack, the y will be pop in the value stack, and then the operation, or sorry, the operators will be stacked in the op stack. Okay. So this is the definition, op stack, and then the value stack. And then we will push, yeah, the y op x in the value stack. This is the function in doop. What about this repeat ops? This repeat ops, if the size of the value stack is greater than 1, and if the precedence of the reference is less than the precedence of the operator stack on the top, then we will do this operation. It means we will do this function. So this is the repetition. We just want to check whether the operators is in the precedence rules or not. So we are going to use this eval expression. The input will be a stream of tokens representing an arithmetic expression with numbers, and the output will be the value or the result. So this is the pseudocode. While there is another token Z, so if the token is still not the N, okay, you will check. Is it a number? If it is a number, then let's put it into the value. If it is not a number, then you can put it into the operator. But before we do with the operators, we will check with the repeat ops. The repeat ops is this one. So we want to check the operator first. Is there any operators that we can use before we push? And then we will do this repeat ops with the dollar sign after we finish all those operations. And at the end, we will return the value. So the mechanism will be something like this one. So I want to check whether 14 is less than equal to 4 minus 3 multiplied by 2 plus 7. Operator less than equal, it has lower precedence than plus or minus. Then this will be the last one. Because it is the last, then we will check from the form. The first, we know that 14 is a number, so we put here. Okay. And then we know that the symbol, this one, is lower precedence. So we put in the operators in the below. And then we have 4, which is the value. We put into the next, the value stack. And then we have minus. We have this operator into the top of the symbol less than equal. Next, we will input the 3 in the top of 4, and then we put the multiply in the top of the minus. Next, we will put the 2, but when we put the 2 here, we know that the multiply has a higher precedence than minus. What we will do here is, before we adding these two, the 2 will be multiplied by 3. Now it becomes 6. And then we will add the operator plus. And after we have the plus here, so we can start again, because the plus and the minus has the same precedence. Then we will do from the left. What we can do from the left is 4 minus 6. 4 minus 6 is minus 2. And then we will do plus 2. Then it will become, minus 2. It will be in this position. And then we add with the 7. Now 7 is in the top. And it is the end of the token. Okay, because this is the end of the token, because 7 is the last value. Then after we have this one, we can do the evaluation. The evaluation will be just do the minus 2 plus 7, it will be 5, and we can check 14 is less than equal to 5, it return false. Okay. So this is the result, false. Okay. Even though I put this one into the value, but actually it is not the value, it is not the number. Thus, this is the statement will give you a false statement. That's the step by step if we want to do with the arithmetic operation. Now you can look that the stack can be applied to any kind of application. There is another kind of algorithm that we can use stack to optimize it. So I took this one from the book author. In their slide, they give one of algorithm, and it mentioned that they do not explain this thing in the book. But it is also good to see this example, because it is an example how the stack can optimize the algorithm. So we are using stack as an auxiliary data structure in algorithm. And we call this is the algorithm for computing spans. So what is computing spans? Yeah, given an array X, given an, okay, sorry, this is too many. Given an array X, the span Si of Xi is the maximum number of consecutive elements Xj immediately preceding Xi, such that Xj is less than equal to Xi. Maybe it is difficult to understand the statement. Let's see like this. We have Xi. Maybe this is, let's say you have the stock price. Okay. And we want to see the span. S is the span. So I give you a small number. In the time 0, the stock price is 6. So the span is 1. It means that if it is the maximum number, okay, the span is the maximum number of consecutive elements Xj immediately preceding Xi, where the Xj is less than Xi. Now you can see here is X0 and X1. Xj, usually we say I will go before J. So here is Xj is X1 less than X0, oh, sorry, less than equal to X0. X1 is less than X0. X1 is 3. 3 is less than 6. Yes. Then, yeah, we will not do the addition. We will just keep the number as 1. Okay. Now, let's check again. X2. X2 is less than or equal to the X1. X2 is 4 less than 3. No. Then we will do the consecutive numbers. So we will add. So this is the second. And then we will check again. X3, is it less than equal to X2? 5? It is less than 4? No. Then we will do another consecutive numbers. So we will add with 1, 3. And then again, we will check. X4 is less than X3. 2 is less than 5. Yes. Then it will return back to 1. Okay. In this case, we want to know how long the numbers will rise. I know that the numbers is rising for 3 consecutive periods. How can we make this span information? So this application is very good for the financial analysis. Okay? So if you want to see your stock, okay, you can see the fluctuation, the dynamic price. And you can see if the price is getting high from day to day, then you can buy. Maybe it will be a profit for you. So this algorithm, yeah, you can make like this one. Now, suppose you have the span algorithm like this, span x comma n. Okay. We have the array x and we have the n integers, and the output will be the array s. So the span. I want to know the span, which is the 1, 1, 1, 2, 3, and so on. Yeah, I will just do with this statement. S is the new array of n integers, then the operation will be n. For loop, because we have from 0 until n minus 1, then the worst case will be n. S equals to 1. Okay, the worst case will be n. Because yeah, I know that the worst case now for the loop is n. Then for all the operation here will be, of course, n. Okay. And we have this one, while s is less than I, and xi minus s is less than xi. So when we are doing with this while, yeah, the condition like what we did before, there is a possibility that, like this one, 3 is less than 6, yes, then you will not do anything. Okay, so the number will be the same, or it will return back to 1. If you are having this problem, 4 is less than 3, no, then you will add the span with 1. If 5 is not less than 4, then you will add this with 1. However, the worst case is will be until n times. Then I can say that this while will work n times, and the for loop will work also n times, because it is n and this is also another n. Then yeah, it will run about O n power of 2. So n operation, and we have another n. So it means n multiplied by n. Now, how if we use stack for this problem? We can say that you keep in a stack the index of the element visible when looking back. So we scan the array from left to right and let I be the current index. We pop index from the stack until we find index j such that the xi is less than xj. So we have the stack, okay? And then if we know that this is the maximum, we keep that part. We set the si equal to the I minus j. And we push x onto the stack. This is the algorithm, and we can say this is the linear algorithm. How we can see this one? Yeah. Each index of the array is pushed into the stack exactly 1. So if I have the array index, let's say x1, so I will push the index 1 into the stack, so it is 1 time or 1 operation. And also we will pop from the stack at most 1. So if I put into the stack the index 1, and I have only 1, and if it is correct with the condition, then it will be popped, and there will be a new index that we can do with the push. So the stack will always only 1, because I want to see what is the maximum number. After we find the maximum number, we will do the addition. So this is the algorithm. We call this is the span through. S is the new array integer, so we have an operation. A is new empty stack. The stack is empty, so it is only one operation. We have for loop. We know that this is n. Now we want to optimize the while. In the previous part, we have the while loop, and we check for every of the array. Now we do not check for every of the array, but we will just check the stack. We want to check if the stack is empty or not. If it is not empty, and if the value in the stack, so the value of the top of the stack is less than the xi, then pop. So if you have like the value of index 0, 6, okay, so if it is 6, then if I have the value of index 1, it is 3. Okay. So 6 is less than 3? No, then we do not pop. Okay. So we just check only one time. And then, yeah, if the stack is empty, you can add with 1. If not, then the element of the span will be I minus the A dot top. And then we can just push another index I. So if we have like x2 is 4. So 4 is less than 6. So sorry, the I is the next index. So I will be added by 1 after this one. So we will check this one. As I is the I plus 1. Okay. We will do with for every 6. This one, after we do the element, this one, we will do the pop. If it is A is not empty and the top is not equal to 1, then we will do the pop. If not, we will push. So if we have the A is empty, we will do this one. If it is not, then I will be minus the top. So we will have the S as the array. Okay. S is the array. Si. So this is the index I. The index I will be I minus A top. So I is the index 0 will be minus by the what we have in the top. Force. This will be if you see the top, what is the top? We just want to get the last element without removing it. So this is the array of integer. Okay. So it is not about the wait moment. This one is I minus. I think this is actually the number of element in the top, not the A top. And then we will put the index I. Yeah, I think the stack is not the 6, okay, but the index. Sorry. If we have the x0 is equal to 6. So we do not put the 6. We put the index. So the index is the 0. Okay. Not the value. Sorry, I missed that one. We just keep the index. That's why we will check again for every of the index. The index is this one. 0, 1, 2, 3, 4. Not the value of this one. That's why we will always check the value, this one. It depends on the index of this I, and actually this is the index of the top value. This is it. Yeah, a top in this case is the index of the top of the stack. Okay. So we can get the value of the span, and if you check this one, it will be n, it will be n, it will be n, it will be n, because it is only if operation, and this if operation is in the for loop. So the worst case will be n, and for this one, yeah, it will be just one time operation, because this one is one time when we push, and if it is pop, it is also one time operation. So the statements in the while loop are executed at most n times, and this algorithm, yeah, runs in the for n times. Okay, then we can say that using the span, it will optimize. It will optimize more than using the while loop or using the loop from the first index to the last index. Yeah, in this chapter, we learn about the ADT, and we learn about some examples like the HTML matching, parenthesis matching, and the operation, the arithmetic operations. And yeah, I explained you one of the problem, how we can optimize the algorithm using stack. Okay. Any questions? We have still 5 minutes. Okay, let's go to the concept of queue. We have stack, and we call the stack is LIFO. What is LIFO? Last in, first out. Okay. The queue, we call it the queue is, yeah, queue is another ADT, abstract data type. And there is an implementation using the array, and we can see some of the operations of the queue. The queue, we call this is another schema of the algorithm with first in, first out. So the QADT stores arbitrary objects. So you can use numbers, you can use string, every objects you have. And there are the basic operations with insertion and deletions. Insertions are at the rear of the queue, and removals are at the front of the queue. So if I have like this one, removal will be at the front and insertion will be in the rear. So it's the same like you are doing the queue in the supermarket, or you're doing the queue on the hospital or in any other kind of real world implementation. So the main queue operations, there are two. NQ, it means we enter the queue. Then we will insert an element at the end of the queue. Dequeue, it means someone's enter the service or someone's remove or go out from the queue. So it removes or returns the elements at the front of the queue. There are some auxiliary queue operations. We want to know what is the first. So it returns the elements at the front without removing it. And length, it returns the number of elements stored. So how many numbers of queue right now? And then is empty. I want to know whether the queue is empty or not. There's one exception that we can use in the queue if it is empty. So if the queue is empty, then we can have the empty queue exception. So here is the figure NQ. So we will do at the back or the rear, and then NQ. We have another numbers 3. NQ, we have another 4. We have NQ, we have 5. We have NQ, then we will put like the next states. Okay. And then if we DQ, then it will start from the bottom. If we DQ, we'll start from the bottom. We DQ, then you can see that when we DQ, we will remove the first element or the front element. So we can see this example. Let's say we have Q. Q is empty. Let's say I'm using list. When we do NQ 5, then I will have an element 5. NQ3, I have another element 5,3. Length Q, it will return 2 because I have 2 elements. If I want to DQ, then the first element will be removed. So the remaining element is 3. If I want to check, is it empty? It will return false because now I still have 1 element. If I DQ, then 3 will be removed. It is now empty. And if I check, is it empty? Yes, it is true. If I want to DQ, then it will return error because now it is empty. You cannot DQ. If you in Q7, then you will put an element 7. And Q9, you will put an element 9 first. And I want to get the first element. So the first maybe person who are in the queue, then it is 7. I NQ, then the element 4 will be inserted. And if I check how many of the queue, then there are 3. And if I want to DQ, then the element 7 will be removed. Okay, let me stop here. Let's have a break. I will continue after the break.